Hospital porters, pride and dignity, stop the New World Order. Welcome to Panwo TV. This is part 4 of my film. Return to Culham. Return to Culham is a sequel to my feature-length documentary Nuclear Fusion Power. And as the name suggests, in the title, I actually returned to the Culham laboratories to go on an official guided tour, which we all sort of like do now. The open evening. Now, these are the photos I took. After we had our lecture, basically we went to the building where they housed the JET experiment, this huge tokamak, the largest, most powerful in the world, basically. The first place ever that achieved nuclear fusion. This is in Oxfordshire, just a few miles from Oxford. As I explained in part 1, it's literally just a quarter of an hour's train ride from Oxford, and very, very easy to get to, very easy to get back from. Now, this here is the first photo I took inside the chamber that houses the JET experiment, the JET tokamak. Now, you couldn't actually get into the place where the JET tokamak actually is. This is a picture of the huge concrete shielding wall, which covers it, and that yellow partition there can be slid back. It's actually a sliding door, huge sliding door that can slide back, and you can see inside. And there's this huge thing about 60 feet high, which is the JET Torus, which I'm a bit disappointed I never got to see that. We went into this chamber, and it's a huge. This is what's called the assembly room that we're in now, which is like where they have a lot of the auxiliary equipment for the JET Torus, and they also use it for training. We had hard hats on, and basically it was quite noisy and it was quite hot. Lots of machinery everywhere. This huge, about 100 foot high. This chamber was enormous chamber. It's rather like the industrial block at my hospital. And I'm looking now towards the concrete partition between the chamber housing the JET tokamak and the assembly hall. There is a radiation risk, right, coming when this thing is operating. As I explained before, it's not like a nuclear fission station. There are no radioactive materials produced that are toxic in the long term. It's when the thing is operating, and when just afterwards, for a time period afterwards, it is radioactive. There's a radiation danger. So it's rather like the X-ray machinery in my hospital. Slightly, probably a bit more extreme than that, but still the same principle. Right, that is another piece of machinery in the assembly room. You can see that, and look at the bottom there. You can see some of my fellow guests, all with those yellow hard hats on, which I had on as well. When you've got, what we do is this here is that there is actually a training machine. It's actually for training the people who use these remote controlled robot arms. I forgot what they call them, but they're basically, it's a remote control device that allows the operator to use a remote control kind of robot like device to get inside the vessel that's inside the tokamak, where it can be highly dangerous. It can be highly radioactive in there. So at the moment people go in there with special suits on, but they're thinking of completely automating it so they can just use these robots. And there's a very, very sophisticated sort of control room where there's these little hand grips. These engineers hold these little hand grips which control these robots, and they have like screens where they can see what they're doing, and it's just like being there. And there's even this sort of like pressure feedback system, so that, you know, when they're tightening a screw or something, it gets harder and harder to turn the control lever, so to match the actual pressure increasing at the other end inside the machine. And the control room is actually about 200 feet away, right outside that chamber. So they're operating remotely. And this is the training vessel. It's a complete mock-up. I'll show you a bit closer. See, we went up some stairs and we went and looked inside the training. This is a mock-up of the inside of the tokamak vessel, and some more people with hard hats on, and I was one of them. I didn't get a photo of myself, unfortunately. I should apologise for the quality of some of these photos, but I was using this old mobile phone that doesn't work anymore, and I still use it for a camera. And it's got a very long exposure, and my hands, it's not best sort of photography environment either, because I had to rush around. But they train these guys by making them play Jenga. It's quite fun. So these engineers sort of like learn to operate these machines by playing Jenga. But that's where they practice. They practice by replacing these insulating tiles. The real ones cost about £2 million each, but they just play around with these little cardboard ones. There you see, this is another piece that is looking towards that the jet chamber. Behind that yellow door there is the jet machine. At the moment, it's all shut off. It's all sealed off because there is a radiation risk in there. And there's some more of the people there with the hard hats on. And you can see this is about 100 feet high. This whole chamber, very hot, very noisy. This here is a doorway leading into the jet chamber. There's a turnstile there, and literally they have to be very, very careful when people go in and out because of the radiation risk. Because it's basically sealed off at the moment, and that is the control mechanism. You can only go. Sorry, the turnstile. You can only go in there if you've got protective clothing on. And there's an office next to it where a guy sits there, controlling people's access to the jet chamber. And I had a quick glimpse, right? Because you go in there and I had a peek through. There's a door open, so you can get a quick glimpse inside. But that's apparently not. It's not dangerous to leave that door open because it's in a sort of like side chamber. That's called I forgot what the guy called it. A heating something or something like that. But anyway, you can see this big cage here, this big fence which is keeping people out. We walk down a little corridor. This is a laser machine here, which is actually used to. It's a diagnostic tool. It monitors the plasma inside the vessel, and this is where the machinery is which works it, and basically fires a laser beam into the plasma. And it's there's something similar on the MAST experiment I'll show you later, but basically they can learn a lot about the plasma from the laser beam, the laser sort of instrument that is used here. Now the guy there was one of the scientists involved on the project, and he explained it to me, and I can't remember exactly what he said. It's complicated, he had to use a lot of specialist language, but I didn't understand all of it. Now this here that's not a very good photo because this is the guy doing the tour, one of the scientists. This is the next one. That's a model of the jet. It's a scale model of the jet. That there is the vessel, and these here are massive transformers. And there's the magnets all around there. You see, and it's like a donut shaped thing. It's cut away there. You see, it's not a complete model. A complete thing goes all the way around. That there is a copper. It's a cross section of the copper sort of like cables, which are the copper magnet power lines. I forgot what he called them actually. Help me out if you know if anyone knows anything about engineering. But this is the size of it. You see how big it is next to that bloke's leg. But it carries an enormous amount of electric power. The vital systems of the tokamak in the vessel are not run off. It's all powered by the national grid, and they use a huge amount of electricity. But it's isolated by a flywheel generator or a flywheel capacitor, whatever they call it. And so if there was a power failure, they would have time to shut everything down before it did any serious damage. Before that hot plasma did any serious damage to the machine. But a lot of the rest of the auxiliary equipment is simply run off the national grid, and they have a huge electricity bill. And the guy was saying at the beginning, this costs £14 billion. This project so far, and that sounds like a lot of money. And some people are saying that's too much money. It's too expensive. All that electricity you're using, and well, the guy Chris, the guy who's running the evening open evening, he said £14 billion is what the BP have to pay to clean up the Gulf oil spill. And he made a good point because, which I do agree with, that is that the use of fossil fuels is incredibly expensive and damaging. So that's a scale model of the jet. I took this outside. I think this is one of the corridors between. We were walking across from the jet building to the MAST building, and that is like a little walkway. You can see it was still quite early. But it didn't come out very well, that photo. But that's part of the yard outside. Now this is interesting, right? We were walking into the MAST building, which is quite an old building, sort of 1950s. It was there before the Culham, before the jet project was built in the old science park. That's a basement down there, and there's a big sign saying no access for basement unless you hear the basement alarm or someone knows where you are. Now I couldn't help thinking to myself, is that James Casbolt's secret entrance to the Peasmore base? I don't think so, actually. I think it wouldn't be that easy, because it wouldn't be that easy to get hold of. Sure, they may have something down there they don't want people going down there because of safety or something, concerns or something, but I don't think an entrance to the Peasmore base would be like that. It could be like a preliminary entrance, and you go in and you walk along, and There's like a huge gate there with guys with guns. I don't know. I didn't go. It's just a possibility, but that's leading down to a basement under the mast building. But as I said, you know, that this was. It's possible that this building could be something connected with Peasmore, because this building's a lot older than the rest of the Culham laboratories. This building was built in the 1950s, as the man said. It was part of the original centre, was there when it was an airfield. So maybe that's what Casbolt was talking about. I don't know. Right. This guy's called Neil Conway. He's one of the physicists working at the centre. And this here is a cutaway diagram of mast, just a bit like the one I showed you of jet back there. Right. This is a cutaway of mast. I mean, he's a really great guy. He was Ulsterman, really passionate about what he was doing. Knew so much. He was talking about it and he was explaining how it all worked. This is just a model. It shows you how it works. It's a tokamak just like the other, except it's spherical and it has a smaller bit in the middle. It's like a cored apple, as he was explaining. And I asked him a couple of questions. I said, well, is there any connection between the fusion project and the hydrogen bomb project? Because, as you know, the nuclear fission power project, it's historically documented, was very closely connected to the Manhattan Project and the weapons system. And he says no, there's no link at all between the project to develop the H-bomb and nuclear fusion power. The fusion power came much later, and it's a completely different set of science relating to the same sort of like nuclear physics. Right, this is what he did was he took us from here up to a higher chamber, and he showed us sort of some of the equipment, some pieces of the equipment that were put on as display pieces. Some of the equipment that's used, including a giant fuse that was about 3 feet long. And it looked like a fuse, and he says, what do you think this is? And I said, it's a fuse. And he says, yeah, it was a fuse. That was a joke. It was meant to be a joke, but it turns out I was right. It was a fuse. It's a giant fuse for, it's only a 3 amp fuse, but it's designed for a massive amount of voltage, so it has to be enormous. Now this is mast. We went into the mast chamber, right inside this huge concrete chamber, and there's these security doors, because when this is operating, you can't go in there because it's too radioactive. You can see I caught Neil there with his arms going up like that, because he was sort of trying to express himself. He's a very, very good presenter. He knew an awful lot. I've got another picture here. That is the actual mast tokamak, which is smaller. I reckon it's about a quarter the size of jet. So it's about 20 feet high or something, or about 12 to 20 feet higher, something like that, smaller. But inside there is the spherical tokamak, and that is officially, it's the hottest place for about 100 light years in any direction. You have to go to some of the really hot stars, light years away, hundreds of light years away, to get anything approaching the temperatures in there, 100 million degrees. It's enormously hot in there, but it can't burn. It wouldn't burn you very badly, because, as I explained in the first film, it's not very dense. There's about 1/100 of a gram of gas dissolved into a vacuum, a huge vacuum chamber, basically. So it's almost a vacuum in there. This is another picture of. Is that the? No. This is another picture of Mars, and that there is called the neutron camera, which is something they use for picking up neutron emissions from the fusion. Because, as I explained in the first film, neutrons are a signature of fusion. It gives up that the neutrons escape from the fusion reaction, which is how the energy is carried, and it's neutrons which will be used to heat up the lithium in the heat exchanger in the prototype reactor they're going to build in France at ITER, the demo. And that's a camera which captures it. It's these neutrons actually which are quite dangerous. When the things operate in it, they can do you a lot of damage, in the same way, as the X-rays do at the hospital. But that's the neutron camera there. So how do I remember all this stuff? I mean, it was last night. Now I was a bit tired last night. That's another angle of the mast. That's the far side of the mast. It's about, like I say, it's like a small cat shape, sort of like that. It's like a cylinder, a sort of squat cylinder, and inside it is the tokamak, and everything around it is the magnets to keep the tokamak in place. To keep the magnets in place for the tokamak plasma, to keep the plasma in place. Now that's another image of the neutron camera, an AC. I don't know what all this is here, but high voltage AC. So that's next to the mast. That there, it looked quite old-fashioned actually. It had these old-fashioned type gauges on, but this is quite new. It started in 2000. That there is the cooling system for the machine. and water comes through there, and they're thinking of changing to a different gas. There's no need for hard hats in this area. These are my fellow guests. That's Neil Conway, the physicist, who works there. That there is something called the Thomson Light Scattering Device, something like that. It was called. I can't remember. Now, yeah, it's what it is. It's one of the diagnostic things. The way it sounded a little bit like that laser thing I showed you for jet. It's they fire these beams of light into the, or they fire these electrons in there and to capture beams. No, the photons or electrons or something like that. I can't remember what he said, but there's a huge lens down there which picks up an awful lot of what's going on. That's from outside Mars. That there is basically the chamber, it's huge concrete chamber that they keep masked in. It's the equivalent of the concrete shield I showed you at the beginning. That's the first photo I took of jet. It's the equivalent for mast is that. All right, that's all the photos. I'm just going to turn the light. I'm just going to turn the light on. I'm going to shut this door as well because my neighbours will start complaining in a minute. Right, I'm going to. For the next part of this video, I just need you to be able to see me. Oh. Right, oh, right. Okay, so that was my return to Culham. Culham Centre for Fusion Energy. Now, I was really, like I said, it was a really good evening. I really enjoyed it, and I want to thank all the people involved, because it was more people than I expected. There was about 100 people there, so it wasn't just like a small group of people going around. There was about 100 people. We were split into groups for the tour. I was in group 5, and there was probably about 20 people or so in my group. A lot of sort of students were there. There was a couple of people who were individuals. There was a couple of kids there, young kids. So it's sort of family outing for some people. But it was really, really interesting. And the guy running it, Chris, who I told you about at the beginning, who I felt, oh dear, all this talk about damn, ID cards and stuff like that. And do you remember at the beginning I was thinking, am I even going to get into the damn place? Those fears were not completely unfounded. I went in there, as I said, and the ladies at reception, really nice. They gave me my badge, my visitor's pass, which I had to wear on me, on my pin up on me. And they said, I'll just give Chris a call. So she gave Chris a call, and Chris Warwick, the guy running, he came and he met me and he said, hello Ben, he was really nice. He walked all the way, it's quite a long walk because it's a big place. It's a good 5-minute walk between the main entrance. I showed you on the map, didn't I? Between the main entrance and the Jet building, which is where the tour started. And it started in a lecture theatre next to the Jet building, but he came and he got me. I came in there. There's a huge group of people there. We were all given those brochures I showed you, and a feedback form, and also I had a cup of coffee. They gave me a cup of coffee and a biscuit, completely free. And you could buy T-shirts there as well. I didn't buy any. They were selling them for £8. These T-shirts saying "Fusion Energy is the future." So I want to really just say to these guys, thanks very much. I had a really good night. Once I got in there, I was nervous when I went in there because of all this ID shit I was telling you about. I was thinking, but once I got in there, absolutely fine. Really, really went well. And the people that I met there are so passionate about it. Like Chris is a scientist. He's a scientist who worked there. He now works in the PR department. He believes wholeheartedly this is the future, and everyone else I met there, that guy Neil Conway, the physicist, who gave us the tour of Mast. Interestingly, we went into the control rooms. I forgot to mention that. Yeah, we went into the control rooms, which is huge rooms full of computer consoles. It looks like a spaceship, almost like a spaceship's cockpit. Hundreds of seats all around. And he gave us a list of what every single one does, all have different groups of things, and the huge computer screens everywhere. We weren't allowed to photograph in there because some of the screens were on, and they were worried about ITT security. But very, very comfortable kind of office-like, cross between an office and a spaceship cockpit, I thought. So I just thought I'd mention that. Yeah, and we met a lot of the people. We went into when we went in there. We went into the engineering control room where the guys were operating the robot arms that go inside the vessels. And there was all these guys just sitting there in their suits, with these little hand grips, these levers, watching what they were doing hundreds of feet away on this screen. And they turned around and waved to us like that. I think they're passionate about it, And I met a young lad. I think he was about 17, I'd say. He was working there. He was helping out with the tour. I think he was 17. I mean, since I joined the ageless movement, I found it hard to judge other people's ages, but as well as my own. But I'd say he was about 17. He's a young lad from Oxford doing an apprenticeship there, and he's learning to be a technician. He's training as a technician, and he loved it as well. He really liked it, and the whole thing is a major local employer too. So they said that nuclear fusion is a solution to our energy problems, and actually, they're right. We know it works. It's been done. I mean, it's simple nuclear physics, which was worked out quite a long time ago. The fusion is possible. Fusion is possible. It's been done in explosions. Of course, it happens in the stars, and it can be done in a controlled environment on Earth. And it was done first at the Culham Centre for Fusion Energy. The challenge in all this development and these huge institutions are about solving the engineering problems, because it works. We know it works. I mean, the challenge is to solve the engineering problems, and these guys are working flat out, and they really are. And they really believe in what they're doing to try and solve those problems and try and make it work. And ITER is about that as well. This huge, much more ambitious project they're starting in France with this enormous tokamak, which is the biggest thing, 4 times or so the size of jet, even. So it's going to be 200 odd feet high. That's all about solving these engineering problems and making a working fusion power station. And they're so passionate and they love what they're doing so much and they believe in it so much that it seems churlish of me to say that I don't think in the long run that's going to be the solution. And I explain why in the first film, Nuclear Fusion Power. Well, if you haven't watched it already, watch it. It's about an hour and a half long, but you need to watch a bit of background for it. Even if it does work, it's when you consider the alternatives, it probably won't get very far once those alternatives are declassified. As I was explaining about cold fusion, I explained before, I was a bit cynical in the first film. I says they're scared it's going to put them out of business. Yeah. And it will, of course. It will put... I mean, if you can create nuclear fusion, which you can turn into usable heat in a test tube with a palladium electrode and some deuterium for the cost of about £10, you've got a choice between using that, something you can put in a little test tube that big, or building something 200 feet high, covering 6 acres that cost £10 billion to do the same thing, which will take much, much longer. Of course, you're going to choose the cold fusion. And the same goes for all these other free energy devices that I discussed in the first film. The Searle effect generator, the Schauberger coil. They're all simple, cheap devices, and they're almost cost free. Whereas, as I learned last night, and I learned from reading that brochure, we are going to have to pay for fusion electricity. It's going to cost as much as fossil fuels. And of course, it costs the development price and the effort in development is enormous. It's been running since 1973. It's still only, they've made progress, but it's still going to take a lot longer. And I'll come on to that point in a minute. So I feel that if these other things I was talking about, like nuclear cold fusion and the other free energy devices, were not true, then I would say, yeah, nuclear fusion is the way forward. All that money, all that effort, it's worth it because of the end result. But the end result, that is usable, cheap, safe, limitless electricity, can be generated anyway from other things, from other technologies, which I've been talking about, which I talk about in the first film. Therefore, I can't. The nuclear fusion project at JET and at MAST and at ITER would not just survive the declassification of those projects. Now, why? So why is the government allowing nuclear fusion to go ahead. I mean, the government has invested an enormous amount of money. Now, I made a mistake before in previous films. I think in my interview with Richard D. Hall on Rich Planet TV, I made this mistake. I said that it was a technological cul-de-sac. And obviously it's not. All right, because it is practically possible. It's possible to rig up a heat exchanger to something as hot as plasma. And they've worked out how to do it, and they're going to test it at ITER when ITER is done. But as I've said, fusion energy is not free energy. It's going to cost money to generate that electricity. It's going to cost as much as fossil fuels or nuclear fission. The problem appears to be, that is the problem. It's going to be free. It's not going to be free. It's not going to be free. It could make it means why it is permitted by the government, for the same way as they allow wind power, because those wind turbines, technically that's the fuel source is free, as the fuel source in nuclear fusion is free. It's just water. But the wind turbines have a massive overhead. I mean, the actual they're very inefficient. Nuclear fusion power obviously is not completely efficient either, because it's going to cost money. It's economically going to be equal efficiency to fossil fuels. That's what they're saying. Equal efficiency to fossil fuels. There's also the time scale. As I said, there's the enormous challenges needed, the engineering challenges needing to make this science work. Taken so long to develop. It's taken 40 years since they first started planning it to get where they are today. ITER is now under construction. It's not going to be. They've said. I mean, it's. You remember in my video about in the last video, in the first video, I tell you about ITER in part 3 of nuclear fusion power. ITER will not come online until at least the late 2020s. I can't remember the exact time scale. It's in the first film. I showed you their website. I can't remember the exact time scale, but it's sort of going to be late 2020s, I think, and then you're looking well into the middle of the century before real power, before the prototype power station has sort of won its spurs, shown its mettle, and can be used as a model to create others. And the guy was saying, there's a lot of other problems going to have to be solved. If this ever goes into mass production, you're going to need to train people. You need to, they were saying, they need the guy doing the apprenticeship. You're going to need more people like that. Many more highly qualified scientists to make it work, and engineers to operate those little robot arms with the little clasping levers. So we could be looking at a century or before it comes online, and in that time, maybe this is why the Illuminati permit it, and this is maybe why they're investing into it, because it's going to take so long. It's a way of kicking the football further down the path. The issues I spoke about in Nuclear Fusion Power, the first film, to do with free energy, the political issues and economic issues to do with it. You can sort of like, it's sort of a method of procrastinating those issues. It's not really, because it's not sort of like, it's because it's not sort of in your face right now. It's not something that has to be dealt with now. It can be relegated to the future quite safely without any sort of serious sort of like, dealings. You don't have to. The Illuminati who are trying to suppress free energy, you don't have to address it right now. If there are such issues with nuclear fusion power, it's not going to be free. Thing is, within a century, I think the population reduction programs, Agenda 21, things like that. That's going to be so far advanced that maybe they're just not. It's not going to be an issue. Maybe they know. Well, they think they know, because I don't think they're going to get away with it. But because they have all these other political machinations up their sleeve, waiting in the wings, that this whole nuclear fusion or no nuclear fusion issue is going to be superseded anyway. Well, what else can I say? That is my return to Culham now. My booking onto the Open evening. I said that I would be well behaved, and I was well behaved. I didn't ask any awkward questions. I just went there and got information. I took some photos and I listened, and it was extremely interesting. And so I'd like to thank everyone who made that possible, like Chris and all the other tour guys, and I want to apologise to them for sort of like my scepticism with a C, scepticism with a C, of what they're doing, because they love it so much and they're so passionate that I feel very churlish actually, and I feel a bit guilty. But if it's true, it's got to be said. So apologies, but this is how I feel about it. I think that what's going to happen is when in the post-Illuminati world, which has to come before this nuclear fusion power is developed, because basically within half a century you're not going to have a planet left, and there's not going to be any people left. So either we're in the new world order, or we're free. It's either one thing or the other. This is why I don't pay into a pension scheme. There's no point. I'm never going to collect my pension, am I? Not at my age, even though I'm ageless. Because basically, if I started paying into a pension scheme now, I know people in the truth movement who have pension schemes, and I think, why? Young people, young people like me, who are as ageless as me, or even more ageless than me, shall I say. They say, oh, I'm paying into this pension scheme, isn't it wonderful? And I'm thinking, why? You know as well as I do that by the time you come to collect your pension, we're going to live in a very different world. Either we'll be in the New World Order, or we'll be in a free world with the Illuminati gone, a post-Illuminati world. Either way, you ain't going to need your pension, are you? You're not going to need it in the New World Order, and you're not going to need it in the post-Illuminati world either. And that's the way I feel about nuclear fusion power. It's basically something that is relegated into this either-or situation, either New World Order or the post-Illuminati world. If it's the New World Order, it won't matter, because basically we'll be in the New World Order. There'll be less than 500 million people in the world, all of them microchipped, all of them cyborgs, all of them slaves to the will of the reptilian elite, on a planet which is a dust bowl, ruined. Or we're going to be in the post-Illuminati world, in which case the Searle effect generator, the Schauberger coil, the Mayer cell, all these other free energy technologies you've heard about, which I spoke about in the first film, will be freely available. They have been developed in secret. There's no need for any further sort of like experimentation. It's simply a case of declassification, and then they can be mass produced. And anti-gravity and things like that. All stuff from the Roswell crash that they found out. So that's how I feel about it. So nuclear fusion, it's interesting. It's the experiments they're doing, but it's something that I don't think is ever going to come to fruition. Well, thank you for watching Panwo TV. I hope you found that interesting. Hospital porters, pride and dignity, stop the New World Order.